Hi, everyone. I think we'll get started soon. So we're going to be talking about using PRs as UI. But first, I want to know, how many people here start a deployment by raising a PR? Just raise your hand. I don't know.
Pretty good.
Who is not raising their hand? That's interesting. You're here. Awesome. Now, how many people follow along the progress of their deployment through their PR? A couple. Okay, does anyone actually control and actuate the deployment on a PR? Okay, we got some good stuff for you. So my name is Chris Reilly. I'm a principal software engineer here at Priceline.com, and I'm newly on the developer platform team. We used to be the pipeline engineering team.
My name is Tyler. I'm the director of the developer platform team here at Priceline. Just to give a little background on who Priceline is, this is our mission statement, to be the best travel deal makers in the world. And the way we do that is by really being a tech company at our core. So we're doing all the really cool cutting edge stuff using Kubernetes, all of the Argo projects. And we're doing all of that to stay up and always get the best deal we can get for you in travel. So we're going to talk through today, giving you some context on how Priceline adopted Kubernetes in the cloud and all that stuff, and then dive straight basically into a demo of how we use PRs to control deployments. We learned a lot of lessons along the way. This has been a really long initiative. And then we have some future growth and stuff that we're excited about to do in the future after we've built this solution. So Chris, give us some context on what do we do at Priceline for Kubernetes?
All right, so we have a small number of large clusters that are multi-tenant, and everything's really kind of a centralized but flexible environment. So we have a golden chart that most applications inherit their configuration from, and from there, everything is orchestrated by the Argo Project tools plus an internal API. And we probably give less freedom to developers than some organizations, but most of that is driven by the fact that we operate in a highly regulated space as a merchant of record. So we have a lot of controls we have to implement, and so we're really focused on developer experience with what we can give developers, and also giving them operational minimizing their operational work as much as possible. So when we set out to build a new deployment system, we really were focused on what can we do to provide something that is familiar to developers and easy to use and has the least amount of cognitive load when it comes to going to prod. And that's a tenuous time, so we want to be able to introduce as many guardrails as possible and give them feedback throughout the process. So we really set out to create a guided path, and we found that GitOps is really wonderful for operations people and operations processes because of its consistency, and the questions that developers have when they're deploying are not necessarily the questions operators have. So we're really focused on how do I fix my thing? Is my thing broken or did it work? Can I move on to the next thing or not? So we wanted to try to create a more curated experience that is collaborative in nature, collaborative with bots and with other people. So we really settled on using the PR to aggregate across all of our tools. So using the PR as a UI allows us to observe updates from clusters across multiple regions. It allows us to actually control the deployment from the PR with SSO RBAC in place, and we can monitor the outcome of tests and canary deployments in a place that everyone already knows, where they're able to access it and familiar surfaces from the web, IDE, maybe even in their pocket. And what we really wanted to be able to do was bring something that tools can't tell you, which is specifically handcrafted guidance about the situations they might be facing during the deployment process. So with that, I'm going to hand it over to Tyler to show you what we built.
Yeah. So here is an example of a regular deployment at Priceline. So you'll see here, a developer has raised a change just to bump an image version tag. For a lot of people who raised their hand at that first question, and this is very normal. You're going to see you're going to raise a change here. And what we use is Argo Workflows to basically hydrate this manifest and to give the user feedback on what their change means. So see in here, it's just a simple image version change, and you'll see 2 modified Argo CD applications because there's a multiple region environment and multi-region application. And then also changes to the rendered, or someone might say hydrated manifest, visible here. And we're using a really cool open source tool called diff with a Y, DYFF, which is YAML-aware diffing. So you can see the actual changes to the YAML that'll go live. And this is to the basically the Helm output of the template. What happens after that is our approval bot. So immediately after it's rendered, the system analyzes the PR to make sure it's a valid change. So you'll see that the first thing says it's the type is valid. We validate some metadata about the application. We'll even validate the security gates of the version being requested. Make sure it's passed all the gating requirements, doesn't have any CVEs, stuff like that. We can also check a lot of other things like cost labels. We have some rollback detection. We have a lot of other things that we don't show in this demo, but it's a highly flexible tool is kind of the point. You can put whatever business rules you need for what you're allowed to do before you deploy in a visible checklist format. So developers know, hey, look, I'm not allowed to deploy. We brought it all the way forward. You don't have a webhook failing, for example. You have a checkbox that says, hey, you're failing a security test. Here's how to fix that. So this is all driven by an internal API. And then after this has been deemed approved, maybe you have the right PR approvals and your rules are passing, we use Argo Workflows to then do a PR approval and then a PR merge. You'll also note that we've used the bot to push to our rendered Kate's manifest repository. That's where our actual Argo CD manifests live. So then this is where our PR starts to talk to us. So you'll see 2 sync started messages, one from each of the applications. And these are just simple pre-sync hooks on the Argo CD application. Again, this is probably pretty simple for the notifications. But then here's where we start to dive into a little bit more bespoke knowledge. So you'll see here, we got this message posted on our PR saying the sync was aborted and our pod probes failed. So the way this was generated was Argo Events is actually listening in the cluster on all of our clusters to detect these kinds of events. I don't know if you know this, but if you're using Argo Rollouts, for example, it's going to sit there and spin, but it's not actually going to not notify the developer. You're going to have to go into a UI and find this error message. So what we do is we pull that error message out based off of Argo Events. We feed that into our internal API. It determines maybe what PR generated this change, and then aborts the sync in Argo CD and tells Argo Rollouts also to terminate and to roll back. And then we grab that error message and provide specific guidance on how to fix it. So you see here that there's a link to our application logs, as well as a link to the Argo UI of the exact pod that's failing. And we provide very clear steps. Hey, look, this has failed. If you try to go there right now, you're going to get the old version because we've rolled it back for you. All the things that we got because we owned the system and treated our developers like customers, and we got feedback like, hey, what does this error message mean? We've crafted these over a long time to make sure that it's really user-friendly. So we're going to fast forward a little bit for the demo. Say the developer then fixes their code, they redeploy, everything's working. So we're going to now, I think it moved. Cool. So now we're going to do the exact same thing, but for our production environment. So a developer is going to raise a production PR. You're going to get the production gate, so they're obviously going to be a lot longer, have more restrictions. And then the sync started message has happened in production. So at Priceline, we do canary deployments, which are super great. You know, provides a lot of feedback, and we don't do the multi-cluster progression. We just do canaries. And you'll see here that we actually provide links to the observability dashboard for what the canary is doing. So we provide the exact links to the deep links to the queries of here's what we're looking for throughout your rollout, and links to the logs. So you can see the logs of the canary pods and the logs of the stable pods. All of this is fed from Argo Rollouts talking to our internal API to generate this comment. So our canary started. That's great. But of course, canaries don't always work. So we'll get this message where it says canary verification is unsuccessful, and we make this really specific so the developer knows exactly what to do. Here's the exact thing that failed. Here's the endpoint that failed. And then you'll see here, though, that we can start to talk back to the PR. So you'll see there's two options here. To proceed, you can approve the canary, right? So you can type this comment, or to roll back, you can click the revert button. So we tell developers how to roll back. But one thing we noticed when we were adopting Argo Rollouts is sometimes developers want to just approve a canary. They don't want to have an auto rollback, and that's permanent because maybe it's expected that your response time deviation. Maybe you've added an external API that has, whatever not great SLA, but you have to deploy it. So then we allow developers to then comment /approve canary. So the system then says, OK, cool, I'm going to allow you to proceed. We've written some custom Lua to skip the right step. And then we go to rolling out to 100% in all of our regions. After this, we provide feedback along the way. So again, if you're using standard sync hooks, you might just get a message through Argo Rollouts scaling to 100%. But you might not know how long it's going to take. Say in this example, this is a real example for one of our applications. We have almost, I think, maybe over 1,000 pods for this application. So it's going to take a long time to roll out. And sometimes developers will get confused if nothing gets posted on a PR for longer than a couple minutes. They're like, hey, is the system stuck? And we get a support ticket for it. Like, hey, look, this thing's broken. So what we've done is we've added this dynamic rollout progress bar that uses a Kubernetes job that runs in a parallel sync wave to the Argo rollout. And it updates this progress bar along the way. So every single minute that it'll go across to say, hey, look, we're still working on your change. It's not stuck. And if an issue did happen during this rollout, you would get a notification, right? So it's always going to be the most up-to-date status. So a few minutes later, again, it'll get marked as completed. You'll see that nice green checkbox, and you know, hey, look, my change is now fully live in production, and you can tell your product people go play with it. It's in prod. So after we're in prod, though, of course, you need to run smoke tests. You need to make sure that, hey, this change is live in prod. We tested everywhere else, but we're going to run our automated test suite. So again, we use a Kubernetes job with a sync wave. So right after the rollout is completed, we go run our integrated test suite. So this follows the similar language and similar like markdown strategy of everything else. It's a really common language. We use a progress bar for showing how many tests are running and how long they're taking. And we even provide a link. If you see the text that says passed, you can go see the test run, and you can see how many tests passed. Maybe one of them passed with a retry in this example. So after this is done, our tests are passed. The PR talks back to us. Again, it says, hey, look, your sync is completed, and you're done. You're completely done with your change. There's nothing else you need to do. This is done on the PR, but this also is backed by an internal API everywhere that you've seen here. So all these events are available on the PR, but also through our internal API, so you can grab this information and reuse it across your enterprise. Yeah, so that was our demo. So we have some lessons that we learned throughout this process. So why does this work for us? So we really needed something that was safe by default. Any actions that a user can do, they should know what the consequences are. So when you approve a canary, you know that you are overriding something that it said it failed. It wasn't in the other actions, maybe something that could delete an Argo CD application, for example. If you delete an Argo CD application within our platform, you have to type a command saying, I acknowledge that this will delete this thing, and this will set replicas to 0. I acknowledge that this could cause issues if this application is still used. We also use automations to ensure deployments don't get stuck or abandoned. So we have continuous crons monitoring our environment to make sure, hey, if this rollout's been sitting in a progressing state for longer than 30 minutes, an hour, we should go ahead and abort that. It's in a stuck state. We need to move on. And again, developers can experiment in QA, but moving to prod has clear goalposts. So we use the exact same language and process for deploying to QA as the same as deploying to production. Production, of course, just has more steps. But if a developer gets used to, oh, I deploy this service and I follow this automated process for QA, then we use the exact same language, so it's not scary to them for the first time they deploy to production, because it's just like deploying to QA with more steps. We also built this as a product, right? So as I alluded to, we treated our customers, our developers as customers. We responded to their feedback. When people were confused about what a message meant, or they were confused, coming to us saying, hey, look, my deployment, my sync isn't starting. Why is it not starting? Oh, because your probe failure has put this rollout into a broken state. Therefore, the rollout can't proceed until we do something. We've brought all those things. We've automated things so that it's a cleaner interface. And then we've made it so that it's easy to use. We also tracked every feature request, and we prioritized them for how many people it affects. And again, there's a ton more features that we didn't get to show in the time that we had. But come talk to us afterwards. We have a lot more detections and stuff that we could show. And we really built an experience that developers love. They don't complain about it. They also aren't asking for Argo CD UI access. I probably could turn off Argo and switch it to another tool, and they would never realize it because they use our system as their one-stop shop for getting everything done. But of course, that's put an onus on us to build the right features and to be the single point of failure. But for us, that's been a great trade-off because now we have a UX that's very consistent and used by all of our developers. But of course, there were some challenges. So Chris, you want to talk about why this was really hard?
Yeah, it's definitely, it was a multi-year, multi-person project to put all of the pieces we have together in place. We were able to do so because the Argo project overall has fantastic, very powerful building blocks, and it does not have a golden path. And that's a good thing because we all have our own paths that we take with these tools. And as we were finding our path, we knew that our developers did need to have one in order for the system to be successful. So we really tried to centralize all the context onto the PR. And when we were first getting started, we had developers in the UI, and they were instructed to abort a rollout, but also terminate any lingering analysis runs. And as we were making the documentation about this, it just kind of felt a little bit wrong to have to give all these steps. So resource actions, they can only act on their own resources and children, but we were able to, with a PR command, act on Argo CD itself with the terminate, and also call the abort resource action on rollout, and we have other examples of that as well, where we kind of conjoin things. And then, of course, solving the multi-region, multi-cluster situation is made simple when everything is just a feed. And now, one thing that is these PR comments do get very lengthy after a while on a super, multi-region deployment that goes on for a long time. But you can put anchor links with subscript, and they go right back to the top. We're able to automate when deployments get stuck because that question came up so much. We do provide deep links into the UI, but people still ask, why is my deployment stuck? So Argo Events was really useful in this regard because we could just filter down right to the Canary pod label and monitor for those events and take action exactly when those were happening. So we learned a lot along the way. We learned a lot about GitHub rate limits.
We also learned that you can give a developer a link, but they will not click it.
So we actually have not one bot. We have four,
five, 10.
Yeah.
Every GitHub app is separate for all the different places.
Yeah, and we have log monitoring for secondary rate limit exceeded. We know that, something's gone haywire because it's in a loop and it's gonna blow through our comment budget. So it's an interesting thing to have a surface that you don't own be your deployment system, but it's also super well supported. Like, I'm not going to say super highly available because powerful platform that is essential to development in general. And so I think now we could talk about what we see the future looking like with PRs. So we really see deepening our scope as we evolve this pattern. We want to have more information and more controls. Like one thing that we've recently added is a CPU monitor. So we check before a prod deploy goes out to see if their Istio sidecars are hitting 200% and throw a warning and say, here's a commit you can do to adjust that. So we're going to continue to make more bespoke actions throughout the path. But then we also want to start to target new and different types of deployments that aren't necessarily Kubernetes. So using the same patterns of raising pull requests, going through the approval bot, getting PR comments, we're targeting deploying to virtual machines and to buckets and all kinds of other platforms. So we think that with that kind of rich guidance and actions, it can be a consistent interface for deployment all throughout our organization. Furthermore, PRs are getting smarter. It's really it's emerging that PRs are a central place for humans and bots to interact, especially around code changes. And we think there's a couple interesting ways this can happen. Agents are reviewing PRs. Agents are raising PRs as you or autonomously. So we want to teach agents how to work with our system effectively. So they use it right and also provide guardrails so they can't use it wrong. And we have a kind of imperative to provide accurate context for them. We also think that LLMs are wonderful to have in the cycle of a deployment, and they can be talking back to the PR, and that can become more of a conversational service for debugging and troubleshooting if you hook them up to the right context. Finally, I'll say I think that Argo Workflows itself is a wonderful, sandboxed, powerful, scalable, and cheap way to run agents. And we look forward to exploring that more in the future as a runtime, something that people can build out easily and scale up as much as Argo Rollouts can, or workflows, which is sky's the limit. So with that, I think we have a couple minutes for some questions.
Go ahead.
Yeah, sure.
How do you handle merge conflicts?
So I can answer that. So there's two things that we do. One, we have basically a merge queue in the background. So we only merge one thing at a time. So if there's two people trying to deploy a dependent service at the exact same time, it'll only take one of those changes, and we order them. So it'll take us to the first one, and we'll tell the user, hey, look, your merge didn't happen. I would say early on, we had much more issues with it until we went with the approach of having a bot fully have a merge queue. You have to go all the way to doing a merge queue. The little hacks don't really work. You?
Tell us how it works with custom resources. If you deploy something that requires an operator to be inside it, what does the comments look like?
Yeah, I can. So he asked about custom resources and how we do reconciliation there. So, for example, we deploy Istio through this exact same pattern. I think we just don't have as much richness. We only give sync started, sync complete, and nothing else for anything like a third-party Helm chart or an Istio resource. Basically, all of these features are tightly linked with our, we call it a golden Helm chart. So if you use our golden Helm chart, you get all the features. If you don't use the golden Helm chart, you still get the baseline sync started it, and you will also get sync fail and some basic hooks, but you won't get the same richness in the same way. So it really helped drive adoption to everybody use the same tool.
Yeah.
Did you ever consider anything else as the kind of entry point other than the PR, like if you've got a messaging system like Slack? Did you consider that as the entry point?
Yeah, the question was, did we consider any other entry points besides PRs for the system? And I think the answer is we did consider a lot, and we do integrate with Slack. We integrate with Jira, Splunk, and these are all surfaces that are used throughout our organization. Some people experience the entire deployment system through tickets, and there's dashboards they look at, and that's how they operate. For us and for the developers, the PR was the most feature rich and scalable. But it's something where IDPs might be the place this is happening in the future.
I want to add, we do have the concept of the commit is the UI. So we live in a world where actual CI/CD needs to take place. So again, not shown, but we have a standardized GitHub action where if you do a build and release, it'll actually go call one of our internal APIs, and it will just do a commit on a branch and auto merge that to the main branch. So you can do an auto image update. And basically the exact same system happens behind the scenes. There is no PR. We actually use commit to put all the comments on there. And I think we have one more in the back.
Is there any way you can just dive one level deeper on the API? Like how much time do you spend keeping it up to date, fixing bugs?
Yeah.
Surface?
I would just say everything's internal, and luckily it's really easy for us to maintain because it's an existing API we had for our internal CI/CD for our last talk. So honestly, there's not much maintenance. It's a Node.js application. We use the Kubernetes API. It kind of just works. We have a large team that develops features, but we really don't get bugs. It's been running on Rails for probably 6 months to a year with no changes. I've been told that our talk needs to end, but thank you so much. If you can definitely come up and we can answer more of your questions. Thank you so much.